Today we're going to simulate an assembly line. We're going to have two parts, the tabletop and the table legs. First I'm going to show you the code, and then we're going to do a demonstration of how it works, serial monitor and on the circuit board. So we're going to have a couple shared variables, or a couple shared, we're going to have multiple variables at different pins. Some of them are going to be the same, so like we're going to have a button, but we're going to have two buttons. We're going to have two light sensors, and then for the motors pins, we're going to have one motor. So it'll just be wired up to pin 8, pin 4, pin 3, but it'll all be on the same motor. For the echo and the trigger pin for the ultrasonic sensor, we'll have two different so since we have two parts, we're going to be using the same ultrasonic sensor, but we're going to have them at different pins. And then we have our two LEDs. We're going to be sharing it for each process. We're going to have two parts that go through three processes each, but these LEDs will simulate like if it is at that station. But first we'll run the first part, and then we'll run the second part after it is finished. And then we'll move on. So our thresholds, we have our light thresholds. For the tabletop, we have our light threshold. For the table legs, we have our distance threshold for the tabletop and our distance threshold for the table legs. Here we have our counters. These counters are going to be used after the process is finished. We'll increment the tabletop count. After the table legs process is finished, we'll increment the table legs. And then after we have one of each part in the assembly area, the table's count will increment at the end. So here we have all our variables set at outputs, inputs, or input pull-up. This is for the LEDs. We have them all at outputs. For the table tops, we have our motor at an output, our light sensor at an input, and then we have our button at an input pull-up. So it'll be high, and what we're going to be looking for later on in our if function is going to be a low. We have our trigger pin at an output, echo pin at an input, and for the table legs we have the same, except the only thing that changes is we're going to add legs to every variable so that we can differentiate. Here we're going to begin serial communication. The first line is going to be assembly line initialized once we upload the code to the Arduino. In our main loop, we're going to call three functions. These are all custom functions. We have process tabletops, we have process table legs, which will be the second part, and then we have our warehouse. So our warehouse function is going to be used last. That's where we're going to store, we're going to increment our table leg count, or our table count, and then we're going to transport it to the warehouse using a simulated conveyor or the motor, and then it will tell us the warehouse inventory count. So in between every or after all these functions have gone, we're gonna set a delay of 2 seconds so that it waits before starting immediately. Here, let's actually change it to 10 quick. Okay, so 10 seconds. Anyways, so moving on, we're gonna have our custom functions. Here we have our custom function for the process tabletops, and then we have a custom function for the process table legs. But first, let's explain the variables we used inside of there. So here's the custom function for the conveyor. So we're gonna void simulate conveyor, that's what we're gonna call it, and then we're gonna be using an interval, or a variable called motor pin. And later on, when we call upon the function simulate conveyor, we're gonna put in that pin the name of the pin we're gonna check. So for example, it's gonna be like motor pin and then legs, or motor pin table or top, and then or motor pin warehouse, so that we know which pins we're using and it doesn't like complicate it. So then in the serial plant, it's gonna say starting conveyor. After the motor pin, or whatever motor pin we're using, after it starts the conveyor, it'll say starting conveyor, and then it'll say digital write motor pin high. This will turn on the motor. we'll have a delay of 5 seconds here, and then we'll turn off the motor, and then once these 3 lines have gone, we'll put in a serial monitor, conveyor stopped. For the light sensor, we're gonna have in the check light sensor, we're gonna have a bool check light sensor, which is we're either gonna get true or false. We're gonna have 2 variables here, the sensor pin and the threshold pin, or the sensor pin variable and then a threshold variable. Later on, when we're calling upon this variable, or this function, I mean, we're gonna just change the sensor pin name and then the threshold pin, or the threshold name. So it'll be like, again, sensor pin top, sensor pin legs, and same for the threshold. So in the first line, it's gonna be checking for the light sensor. So in the serial monitor, that's what it's gonna show, and then it will keep checking. This line is gonna make sure that it keeps checking until it is true or triggered, and it won't move on until that happens, so that it doesn't skip the first process. And then this line is gonna check the light sensor, and then the next 2 lines are gonna be in the serial monitor. The first line is gonna show light value, and then the second line will actually be the light value that it is checking in the light sensor line right here. So then we have an if statement. So if the light value is greater than the threshold, then it will do these lines of code right here. So it'll say item detected in the serial monitor. The cutting process has been initiated. It'll turn on the red LED to simulate that the item has been detected, or the material. It'll delay for 2 seconds, turn off, and then it'll come back true. So then if it comes back, or because it comes back true, it'll proceed. And then we have a delay of 1 second to avoid rapid light value reading, so that it doesn't like read the value very rapidly. And then we have a return false. So this to ensure that it doesn't move on. Then we have our cutting process custom function. So we're going to be using a parameter called string part type. So basically, so that we don't have to write up 2 different codes, well, the same codes for both parts. We're just going to use the parameter string part type, and then we will put, for example, we'll put tabletop, or we'll put table legs, and it'll just function. It'll make it so that we don't have to write the same code twice, because if not, then we're just going to have to write out the same code, but we're just going to have to use different different names for everything, so it avoids us having to do that. So first we'll have the serial print, or the serial monitor say starting cutting process 4, and then whatever we put in our part custom function, it'll say that. So like, for example, right here in the serial print line part type, we can put we'll put tabletop, or we'll put table legs, and then it'll say starting cutting process for tabletop or table legs. Then we'll have a delay of 5 seconds. Those 5 seconds are going to be to simulate that the part is being worked on, or cut, I mean. And then once it's finished, it'll say cutting process complete 4, and then again you put the part type, so table legs or tabletop, and then the green LED will turn on to simulate that the process is finished. We'll have a delay of 2 seconds, and then it'll turn off the green LED, and that is the cutting process function. So then we have the second process, which is where we add features. So for example, for the table legs, it'll be like screws, so that we can screw on the legs to the tabletop. And for the tabletop, it'll be like holes for the screws. So we'll just be adding features. But we're going to use the button pin and a string part type. So we're going to be putting later on, like for example, we're going to be putting the button and then the name assigned to that button. So button pin legs, button pin top, and then we'll put the type of what's it called? The type of part that we're using. So the first lines, it'll wait for, or it'll print waiting for button press to start. Second process 4. So, and then it'll do depending on what name we put on in the part label or in the part function. Like for example, tabletop or table legs, then it'll show that. So it'll be like waiting for button press to start second process for tabletop, or waiting for button to start second process for table legs. And then while the button is so this line is to ensure that it keeps checking until the button is triggered. So once we click the button, it'll be low, and it'll ensure that it doesn't skip it, that it doesn't skip this process and then move on to the third process. So then if the button is triggered, it'll say button pressed, process 2 starting 4, and then again we put the part type, so table legs, tabletop. The red LED will turn on as soon as we have clicked the button to simulate that the operator like initiated the process. It'll wait for 2 seconds, turn off the red LED, and then it'll say adding features 4, and then the part type, so table legs, tabletop. Wait for 5 seconds, and then it'll simulate that'll simulate that the process has been or it is going through the process. Then the green LED will turn on to simulate that the process is finished, and then it'll say process 2 completed 4, and then again part type, so tabletop, table leg. Then we wait 2 seconds, and then the green LED will turn off, and that's the coding for the second process, so step 2. And then here we have our function, custom function to check the ultrasonic sensor. So we're going to be using these variables later on in our when we're using them in our custom part functions. We're going to be changing it to the pins that we're actually going to be using for those parts. So like for example, trig pin, or the variables we're going to be using, so like trig pin top, trig pin legs, echo pin top, echo pin legs, and yeah, it'll change depending on what part we're using. So but once that happens, so here we have a variable for the duration and then a variable for the distance. And the first thing it'll do is it'll wait for, or it'll print waiting for ultrasonic sensor to detect an object, while this variable right here will check and keep checking until it is triggered. That way it doesn't move on. And then once it is triggered, or once it is triggered, it'll select the trigger pin at low, and then it'll wait 2 microseconds, which is let's see, 1 microsecond is 1/1000th of a millisecond, so it's very small. And then this line will set the trigger pin high, and then we'll have another delay of 10 microseconds. And then this next line will set the trig pin at low. And then here we have our lines for the duration. So we're going to be using, we have the echo pin, we're going to set it high, and then this is to make sure that it has like a timeout, because earlier it wasn't working, so we put a timeout so that it checks the ultrasonic sensor, what's it called, so that it checks it without marking 0. It was marking 0 earlier. So next we have our distance, and it's going to be the duration, so this right here, and then we're going to multiply it by 0.034 and then divide that by 2. This will calculate the distance based on the duration and the speed of sound. And then we're going to have, in the serial monitor it'll say distance, and then it'll serial print the actual distance, and then it'll serial print that in centimeters. So then we have our if statement, so it'll be if distance, so if the distance is less than or equal to the distance threshold, which is like 10, as long as it's between 1 and 10 and the distance is greater than 0, so it's not 0, so it could be like 4, 3, 7, then it'll proceed to do these next lines of code, which will be to put in a serial monitor, object detected, painting process initiated. It'll turn on the red LED to simulate that the ultrasonic sensor has been triggered, or to simulate that the atom has been detected. It'll turn off the red LED after a 2-second delay, and then it'll return the value true. Then we have a delay of 1 second, and then we have a return false to ensure that it doesn't skip the function. And then, so that's the code for the ultrasonic sensor function. And then now we're moving on to the painting process. So this is going to be a custom function as well. It's going to start off by saying starting painting process 4, and then the part type, it'll change depending on what part custom function we're using. Then we'll have a delay of 5 seconds, and then it'll say painting process complete 4, and then again it'll depend on what part we're using. And then we'll have a digital write, which will turn on the LED, the green LED, and this will simulate that the process has been completed. It'll have a delay of 2 seconds, and then it'll turn off the green LED. So here we have a void. Another this is gonna be our basically our custom function to increment our tabletop count and then our table legs count. So we're going to be using the parameter string part type. So we're going to be basically, so we don't have to duplicate the code, we're going to have if part type equals tabletop, then the tabletop will increase. And once it increases, it'll say tabletop complete. It'll say the total number of tabletops, and then it'll put the value of the tabletop. And if else, so if it's not this, then it'll be this, which is if part type equals table legs, then the table legs count will increase. The serial print monitor will say table legs complete, total table legs, and then it'll say the actual number of the table legs count. So that's the finalized part. That's going to be to increment the tabletop and the table legs count. And then we have our custom function for the warehouse. First, it's going to say checking for assembly. If the tabletops, or if the tabletop and the table legs count is greater than 1 or greater than 0, then it'll subtract 1 material from that count. So let's say the tabletop count is 1 and the table legs count is 1. It'll subtract 1, so we'll end up with zeros, 2 zeros, and then the table's count will increase. Then it'll say table assembled. Then it'll print the number of tables in the warehouse, and then it'll say tables. Or I mean, yeah, the number of tables in the warehouse. So if we go through the process, 2 parts twice, we'll have 2 tables at the end. And then it'll move the table to the warehouse, and we'll simulate that by turning on the motor high for 5 seconds, turning it off, and then it'll say table successfully stored in the warehouse. So that's all our custom functions. That's for the one for the warehouse. And then now let's move on to our custom functions for both parts. So here we have our first part. We're gonna have 3 processes for it. So we're gonna have serial print, say processing tabletops. That way we know which part we're on. And then it's gonna simulate we're gonna call the simulate conveyor function, and then we're just gonna put the right motor variable. So for the right motor variable would be motor pin top. Then we're gonna call the check light sensor function, which is to check the photoresistor to make sure that the photoresistor is being triggered. If it's triggered, here we have the right variables. We have the lights. So earlier I just said light sensor, and then light or threshold. Now we have light sensor top and then light threshold top. So we're gonna call that, and then if that's triggered, then it'll call the cutting process, or it'll trigger the cutting process variable, and then we're gonna put tabletop so that it knows what variable we're doing it for. And then we have simulate conveyor again, and then we're going to be using the same code like this one. We're just going to be putting the motor pin top variable in it. And then if else, If anything else happens, then nothing happens. Then we move on to the second process. We're just going to put the button top, and then we're going to put the type of part type. So we're going to set it for tabletop. Then we're going to simulate the conveyor again, delay it for 1 second, and then here's where we check the ultrasonic sensor, and then we're going to set the according variables in here, and then we'll call upon the painting process variable. We'll call upon the finalized part. The painting process variable is going to perform the cutting process, so it's going to be the first step, and then, or the last step. And then the finalized part is going to be to increment the tabletop count as we saw earlier. And then we're going to simulate the conveyor moving again, and then once that's all done, it'll say moving completed tabletop to assembly area. So basically, this variable, this custom function is basically gonna it's gonna trigger. We're gonna be looking for a trigger at process 1, which is gonna be the light sensor. Once that item is triggered, or once that light sensor is triggered, then it will go through basically the cutting process function. So it'll turn on a LED, simulating that it has been detected, turn off, go through the process. Once the process is done, a green LED will turn on, and then again, here we go, the conveyor will move. And then when we move to the second process, it'll go through that same process again. They're all going to go through the same process. The green LED, or the red LED, is going to be turned on when the item is detected by the light resistor or light sensor and ultrasonic sensor, or if we're triggering it by a button. So once our inputs are triggered, the red LED will turn on. It'll turn off. Process will start. Once the process is complete, which is 5 seconds, duration of 5 seconds, the green LED will turn on. And then once the green LED turns off, we'll call upon it, or simulate conveyor, and it'll move the part it'll simulate moving the part to the next step or to the assembly area. And so here we have the same thing for the check ultrasonic sensor. Basically, it's gonna do the same thing as the light sensor. It's gonna check if the ultrasonic sensor has been triggered. We're basically gonna do it in the same order. It's gonna be, so we're gonna call upon our simulate conveyor. We're gonna have a delay. We're gonna call upon our check ultrasonic sensor, and if it is triggered, then it'll do the painting process variable, and then it'll do the finalized part variable, which is to increment the tabletop, and then it'll simulate the conveyor again, and then yeah, that's the code for the process tabletops. So all of this is going to happen in part 1, and then it'll be the same for part 2, except the only thing that changes is the variable names. So yeah, and here we have motor pin legs for simulate conveyor, and in process tabletops we have motor pin top for simulate conveyor. That's why we have all these extra variables. Like here we have motor pin top at 8, motor pin legs at 4, and then motor for the warehouse at 3. That's why we have all these extra ones, so that, because they're for different parts. That way we can wire it up, so it's a little more easier to understand. But yeah, so that's all our code for this project. Now let's explain our circuit board. In our circuit board, we have 2. All our variables are wired up to different parts. So for example, the red LED, since they're shared, we're just going to be using pins 6 and 7. And then for our buttons, to trigger our second process for both parts, we're going to be using 2 buttons. So if I click this, this is going to be the circuit board for process 1. This is going to be mainly the second part circuit board. But for the third process, for both parts, we're going to be using 1 sensor. And this is going to be our only ultrasonic sensor. But it is shared. As you can see right here, we have basically our first set of pins to the first part. That way we can reuse it. But we have both our echo and our trigger pins for both parts wired up to this sensor, so we can share it. And then our motor will be the one simulating the conveyance. The little fan moving is the conveyor currently in use. And then we have 2 light sensors. So for part 1, we can't use this one. It won't trigger anything. And vice versa. This one will not trigger part 1, and this one will not trigger part 2. And the same for the button. The button over here will not trigger the process 2 for part 1, and vice versa. So all the inputs are basically laid out so that they either work the same for different pins or different inputs for the different parts. So these are part 1, these are part 2, and then we share the LEDs. And this is how we wired up the parts. It's kind of everywhere, but it all works. So now let's simulate the circuit board first. Okay, so first it'll start the conveyor and it'll move the part to the first step. Once the light sensor is triggered, we have enough light to trigger the first part light sensor. The red LED will turn on, it already did. It'll turn off, the process will go for 5 seconds, and then once the green LED turns off, or turn on and off, it'll simulate that the process has been completed. Now it's moving on to the second part, which we already saw. Sorry, I'm going a little slow. Then it will wait for the button on part 1 to be triggered. So once we trigger that, the red LED will turn on, simulating that the operator has initiated the process of adding features like holes for screws for the tabletop. The first process already went, which was for the cutting. So it cut the tabletop material to make the shape of the table. Now we're at the second process, which is the adding features process. So here it's gonna, once we activate this button, it'll trigger the red LED, which will then start the process once it turns off. So here, as you can see, then it'll turn off, wait to simulate that the process has been going through. Once the process is complete, the green LED will turn on. Once it turns off, it'll move the item to the third what's it called, the third part. And then, so my hand was in the range of the ultrasonic sensor, so then the third process initiated. And then once all 3 processes are done, then it'll increment the tabletop count, and then it'll turn on the conveyor again to what's it called, to move it to the assembly area. So after the part 1 processes are done, it'll immediately move on to the second part. That's why it's checking in the serial monitor the light value. So right now it's doing part 2. So for part 2, I don't have a light, so we're just gonna trigger it with my phone screen. Here, 1 second. Okay, give me 1 second. Alright, give me 1 second. Here, let me just update it real quickly. Okay. Okay, we're just gonna run through that one more time. Okay, so the conveyor will turn on, and then the part 1 will go through. Once the process part 1 is has gone through the process, the LED will turn on. Motor, or the conveyor, will move the part to process 2. Now it's waiting for us to initiate the part 2 process. LED will turn on, process will go. Once it is done, green LED will turn on, and then Our conveyance turns on again, moving it to process 3. There's enough light in the room to activate process 3, so the red LED turns on once it detects that. It'll go through the same process again, and then it'll move to the assembly line area, or to the assembly area. During this, it'll increase the tabletop count. Now it moved on to part 2, so it moved the wood or the material for the table legs. It moved it to the what's it called? It moved it to the process 1. So the light sensor over there was enough light to trigger it. So that's what we saw earlier. Now it's on process 2. It's waiting for us to activate it via operator triggering. So for example, what I explained earlier, this button will not trigger part 2, as you can see. But if we trigger this, there we go, then it'll trigger it. So yeah, I went through the process. Once the process is complete, the green LED turns on, and then it moves the part to part 3. Yeah, my arm's in the way. So the range is only between 1 and 10 centimeters. So as long as my hand is in front of the ultrasonic sensor, then it'll trigger process 3, which is to paint either the tabletops or the table legs. And then at the end, it'll move on the conveyor again. And then once both processes for both parts are done, it'll start moving, or it'll basically assemble one table in the assembly area, and then it'll show the number that's going to be in the warehouse, and then it'll move it to the warehouse. So yeah, now let's actually show it in the serial monitor. Alright, so here we're gonna show it real quick. Okay, so it'll start by saying processing tabletops. It'll start the conveyor. Then it'll check the light sensor. The light threshold is 600, so it already surpassed it. It'll start the cutting process, and then the cutting process. Once the cutting process is complete, it'll start the conveyor again, moving it to the second part. Once it stops, it'll wait for the button press to start the second process for the tabletop, which is to add hole screws. Here. Okay, so we clicked it. Now it's it'll say the button has been pressed. Process 2 is starting for the tabletop. It'll add the features for the tabletop. Process 2 is completed. That is when the green LED will go turn off. It'll start the conveyor, and then it's waiting for the ultrasonic sensor to detect an object. It detected a number of 3. Since that's in the range, it'll initiate the painting process. Once that's done, it'll what's it called? Completing. Hold on, sorry, it's going too slow. It's going too fast. Okay, let me go back a bit. Okay, so where were we? Okay, so the conveyor stopped. Now it's moving the. Okay, give me a sec. Okay, so here's where we were. Basically, starting painting process for tabletop. Okay, so once all 3 processes are done, so once the painting process is done, it'll say tabletop complete, and it'll increment the tabletop count, starting the conveyor. A second. Where is it? Tabletop count. Yeah, so then it'll start the conveyor, simulating that it is moving to the assembly line, or to the assembly area. And it'll say that in the serial monitor, like right here it says moving completed tabletop to assembly area. And then it'll move on to the second part. So now it's in the second part. It's processing table legs, starting the conveyor, moving into the process 1. Then it's going to start checking the light sensor. The light value is 604. The light threshold for part 2 is 590. since it's 604, it triggered the light sensor, and then that turned on the red LED, which it says here, item detected, cutting process initiated. So then it'll start cutting the cutting process. This is when after the red LED turns off. Then once the cutting process is complete, it'll turn on the green LED, and then once the green LED turns off, it'll start the conveyor and start moving it to process 2 in part 2. And then now it's waiting for the button press to start the second process for the table legs. So here, trigger it. Like I said, this button will not trigger it if it's on part 2, or if it's on the table legs part, it won't trigger it. Table leg or tabletop buttons will only trigger tabletop, and table leg buttons will only trigger tabletop or legs. So here, there you go. It's been triggered. Now it'll do the same for the same as part 1. Then it'll start the conveyor. Here, we're gonna trigger that. Okay, so it did 3 centimeters, and the range for part 2 is 1 through 8. So since it's 3, it triggered the process for part 2. And then, okay, so now that the total count for both parts is 1, it'll move it to the assembly area, and then once it moves it to the assembly area, it'll check table has been assembled. Then it'll say number of total tables in the warehouse is 1. It'll move it to the warehouse, and then it'll say table successfully stored in warehouse. Now it'll restart. So now it's starting part 1 again. So here we're gonna run it so that we can see what happens again here. So now we're at the button. Okay, so we're gonna trigger the button just so we can see the warehouse count increase. So then, yep. It's starting the conveyor. Sorry, I have to hold up the motor every time it does that. Okay, so it triggered 4 centimeters. Okay, the object was detected, and then the process is done. Again, the trigger. Okay, conveyor started. Okay, now it's moving it to the assembly area. Okay. There, the first process for part 1 or part 2 was triggered. Now it's basically went through the whole process 1. Now it moved into process 2 and part 2. It's all labeled in there, so it'll say for what part it's working on. If it's table legs, it's part 2. If it's tabletop, it's part 1. And then for each part, it'll basically go through the same 3 processes. The only thing that's different is like the buttons. So now it's waiting for our operator to start process 2. Yep, there we go. Yep, process is done. Start the conveyor. Go into process 3. It's going to be triggered because my arm's right there. 3 centimeters is what triggered it. Yep. Okay, the process is done. Start the conveyor again. It'll move it to the assembly area. Now we have 1 and 1 in the assembly area. So another table assembled. Now there's 2 tables in the warehouse. Now it's going to move it to the warehouse. Yep, there it started in the warehouse. And then again, now it's gonna repeat the loop. So once the table has been assembled and it's been moved to the warehouse, it'll again start the loop at part 1. Then it'll move on to part 2. And then once both parts are assembled, it'll check if there's enough to assemble a table. And then it'll increment the table count, decrease the part counts. So if we have 1 and 1, it'll decrement both parts so that it equals 0. And then it'll move it to the warehouse and then show the inventory count for the warehouse. And yep, that's the video.